10 miles from the Hawaiian coast, in the pre-dawn hours of that infamous December morning in 1941, a young Japanese naval officer named Mochitsura Hashimoto watched a midget submarine slip away into dark waters. He served as torpedo officer aboard the submarine 124, and what he witnessed in the following hours would shape his understanding of modern warfare. The massive aerial assault on Pearl Harbor unfolded exactly as planned, with Japanese aircraft transforming the American Pacific Fleet's anchorage into an inferno. Across the Pacific theater, Japanese officers celebrated what appeared to be an overwhelming victory against an adversary they had been warned possessed unstoppable industrial power. The mood aboard Hashimoto's vessel reflected the broader sentiment throughout the Imperial Japanese Navy. Fellow officers spoke with confidence about how American naval strength had been permanently crippled, how Japanese technological superiority would guarantee continued dominance across the Pacific. None of them could have imagined that the burning wreckage at Pearl Harbor contained within it the mathematical certainty of Japan's eventual defeat. The weapon that would ultimately destroy the Japanese Empire was already being loaded into American submarines at that very moment, though it was so fundamentally defective that Japanese intelligence analysts would cite it as conclusive proof of American technological incompetence. The true story of the Pacific War would be written not in the famous carrier engagements that historians would later celebrate, but in the unglamorous technical failures of American torpedoes. These failures would paradoxically evolve into the most devastating submarine campaign naval warfare had ever witnessed. Both sides entered the conflict with fundamental misunderstandings about their opponent's capabilities, technological blind spots that would prove catastrophic in different ways for each nation. The pattern of mutual contempt and technological dismissiveness had established itself well before the first Japanese bombs struck Oahu. The intelligence failure that would haunt American naval operations began on May 13, 1940, when an unidentified source walked into the United States Naval Attaché's office in Tokyo. The identity of this individual remains classified even decades later, but the information provided should have revolutionized American naval planning. The source delivered comprehensive intelligence about the Type 93 oxygen torpedo, a weapon that Allied personnel would eventually nickname the Long Lance, with a mixture of respect and fear. The specifications this mysterious source provided were extraordinary enough to strain credibility among Western military analysts. The weapon could reach targets beyond 22,000 yards while traveling at 48 knots, or extend its range to an almost unbelievable 33,000 yards at reduced speeds. Each torpedo carried over 1,000 pounds of high explosive. The source included technical drawings showing the internal mechanisms, performance data from Japanese testing programs, and operational doctrine explaining exactly how Japanese destroyers and cruisers would deploy these weapons during night surface engagements. The Office of Naval Intelligence conducted a thorough evaluation of this intelligence windfall. Analysts forwarded the material to the Bureau of Ordnance for technical assessment, expecting confirmation that would necessitate immediate countermeasures. Instead, the Bureau's response reflected assumptions that would prove disastrously mistaken. The experts dismissed the entire intelligence package. Their reasoning embodied prejudices that permeated Western military thinking about Asian military capabilities throughout this era. Japanese engineers, the Bureau concluded with bureaucratic certainty, simply could not have developed torpedo technology more advanced than American weapons. The concept of using pure oxygen as an oxidizer, while theoretically possible, was deemed too dangerous and too sophisticated for an Asian naval power to implement safely at scale. The intelligence report was archived and essentially forgotten. As tensions with Japan escalated through 1941, this failure to take enemy capabilities seriously would exact a terrible price. The dismissal reflected broader Western contempt regarding Japanese military competence in the years preceding the war. Admiral Richmond Kelly Turner, who would later distinguish himself commanding amphibious operations and earn multiple Navy crosses, had testified before Congress in 1940 with shocking assertions. Japanese pilots, he claimed with the authority of high rank, suffered from inherent racial characteristics that made them inferior aviators. These supposedly scientific assessments insisted that Japanese flyers lacked adequate night vision for effective combat operations, that their technical training was substandard compared to Western programs, that their aircraft were merely copied from Western designs using inferior metallurgy and manufacturing techniques. Army Air Corps intelligence documents from 1941 stated with confidence that the Zero fighter represented nothing more than a derivative of obsolete American designs. These assessments predicted the Zero would prove no match for American aircraft in actual combat conditions. Reality would demonstrate otherwise with brutal clarity. In the opening months of the war, Japanese pilots flying technically superior aircraft and employing sophisticated tactical doctrine would dominate the skies over the Philippines, Wake Island, and the Dutch East Indies. American pilots who survived these early encounters would report with shock that Japanese aircraft were faster, more maneuverable, and better suited to Pacific conditions than anything in the American inventory. The cost of ignoring pre-war intelligence about the Long Lance became apparent almost immediately after Pearl Harbor. Throughout the Pacific War, 7 American heavy cruisers would be destroyed by Type 93 torpedoes. The cruisers Quincy, Vincennes, Astoria, Chicago, and Northampton all fell victim to Long Lances fired from ranges that Allied commanders believed impossible for any torpedo weapon. 9 destroyers were sent to the bottom by these same weapons. Even the fleet aircraft carrier Hornet, already damaged by dive bombers during the Battle of Santa Cruz, would receive her death blow from destroyer-launched Type 93 torpedoes. The human toll was staggering. Over 3,000 American sailors died as a direct result of Long Lance hits. In nearly every case, the ships involved believed themselves safely positioned beyond any conceivable torpedo danger. Lookouts scanning horizons saw no enemy vessels close enough to threaten their ships. Captains maneuvering their vessels operated under intelligence estimates of Japanese torpedo capabilities that were catastrophically wrong. Then Long Lances, launched from cruisers and destroyers 15 or even 20 miles distant, would slam into hulls with devastating explosive force. The first major encounter that demonstrated Long Lance capabilities came during the Battle of the Java Sea on February 27, 1942. Dutch Rear Admiral Karel Doorman commanded a hastily assembled force of American, British, Dutch and Australian cruisers and destroyers, sailing from Surabaya to intercept a Japanese invasion convoy approaching Java. His force consisted of the heavy cruisers Exeter and Houston, the light cruisers De Ruyter, Java and Perth, plus 9 destroyers representing 4 different navies. These ships had never trained together as a unified force. Their crews were exhausted from months of continuous retreat across the Pacific and Southeast Asia. Communication between vessels was hampered by language barriers and incompatible radio equipment. They faced a Japanese force that had trained together for years and operated under unified command. The engagement began at 4 in the afternoon when opposing forces made visual contact. From distances that appeared safely beyond Allied torpedo range, Japanese heavy cruisers Haguro and Nachi, accompanied by light cruiser Naka and supporting destroyers, maneuvered to bring their torpedo batteries to bear. At 16:33, Naka launched 4 Type 93 torpedoes at 15,000 yards range. Her escorting destroyers followed immediately, launching 27 additional torpedoes between 1640 and 1645, from ranges between 13,000 and 15,000 yards. At 1652, the heavy cruiser Haguro added 8 more torpedoes from the almost unthinkable range of 22,000 yards, well over 11 nautical miles. The sea between the Japanese and Allied forces filled with nearly 40 Long Lances running at 12-foot depths. The oxygen propulsion system produced no telltale wakes, no visible bubbles that Allied lookouts and sonar operators were trained to detect. American and British torpedo doctrine assumed much shorter engagement ranges. Allied vessels saw nothing until weapons were already upon them. At 1713, 1 Type 93 struck the Dutch destroyer Kortenaya amidships. The half-ton warhead detonated against the destroyer's thin hull plating with catastrophic effect. Kortenaya broke in half and sank in less than 2 minutes. Most of her crew of 150 went down with the ship. Allied commanders, unable to comprehend torpedo attacks from such extreme ranges, concluded that submarines must be responsible for the attack. Throughout the remainder of the battle, Allied vessels maneuvered frantically to avoid what they believed were submarine-launched torpedoes, disrupting their formation and preventing coordinated attacks on the Japanese surface force they had been sent to stop. The battle continued for 7 brutal hours as Dorman attempted repeatedly to reach the invasion transports, while Japanese surface forces maneuvered to block him. The heavy cruiser Exeter took an 8-inch shell hit that penetrated her boiler room, reducing her speed and forcing her out of the battle line. The British destroyer Electra was sunk by Japanese gunfire after making a courageous but ultimately futile torpedo attack of her own. Dorman's force, reduced to 4 cruisers after American destroyers withdrew due to fuel and ammunition shortages, continued searching for the invasion convoy through the night despite mounting losses and crew exhaustion. At 23:25, Japanese cruisers Haguro and Nachi, tracking the Allied force by radar, launched another spread of torpedoes from long range. At 23:32, one Type 93 struck the light cruiser Java. The explosion ignited her magazines. Java disintegrated and sank almost instantly, taking 512 of her 600 crew members with her. Minutes later, at 23:38, another long lance struck Dorman's flagship De Ruyter. The torpedo detonated against the cruiser's ammunition magazines, triggering a catastrophic secondary explosion. De Ruyter broke in half and sank within minutes, killing Rear Admiral Dorman and 345 of his crew. The Battle of the Java Sea cost the Allies 2 light cruisers, 3 destroyers, and approximately 2,300 sailors killed. Japanese losses amounted to 4 transports accidentally hit by torpedoes from their own cruiser Mogami, plus minor damage to a single destroyer. The invasion of Java proceeded without further interference. More significantly, the battle had demonstrated the lethality of the Type 93 torpedo, while simultaneously revealing Allied inability to counter it effectively. Yet American intelligence analysts, studying battle reports and interrogating survivors, refused to believe that surface ships had launched torpedoes from the ranges reported. The assessment remained fixed. Submarines must have been responsible. Japanese surface torpedo capabilities were comparable to Allied weapons, and reports of extreme-range torpedo attacks were exaggerations by exhausted crews under extreme stress. This pattern of denial continued at the Battle of Savo Island on August 9, 1942, which would become one of the worst defeats in United States Navy history. At 1:43 in the morning, Japanese float planes dropped parachute flares over the Allied cruiser force protecting the Guadalcanal landings, silhouetting American and Australian ships against the night sky. Within minutes, Vice Admiral Gunichi Mikawa's force of 5 heavy cruisers, 2 light cruisers, and 1 destroyer had closed to what Japanese doctrine considered ideal torpedo range. The battle lasted 32 minutes. When it ended, the Australian heavy cruiser Canberra was sinking, having absorbed 2 Type 93 torpedo hits and 24 8-inch shell hits. The American heavy cruisers Quincy, Vincennes, and Astoria were all aflame and would sink before dawn. The heavy cruiser Chicago limped away with her bow blown off by a torpedo hit. Over 1,000 Allied sailors died that night, trapped below decks as their ships burned and sank, or killed instantly by torpedo detonations that broke their vessels apart. American survivors reported torpedoes coming from impossible ranges and directions, weapons that left no visible wakes, detonations from angles that suggested Japanese torpedoes could somehow turn and maneuver after launch. Intelligence officers dismissed these reports as combat confusion, the natural tendency of traumatized survivors to exaggerate threats and rationalize defeat. The official assessment remained unchanged. Japanese torpedoes were roughly equivalent to American weapons, perhaps marginally better in certain characteristics, but not dramatically superior. This willful blindness to mounting evidence would persist until 1943, when examination of intact Type 93 torpedoes recovered from sunken Japanese destroyers finally confirmed that the pre-war intelligence had been accurate all along. By that point, thousands of Allied sailors had died, and dozens of ships had been lost to a weapon that American intelligence continued to insist couldn't possibly exist as described. This stubborn refusal to acknowledge Japanese technological capabilities mirrored Japanese attitudes toward American weapons, creating a symmetrical intelligence failure that would have profoundly different consequences for the two powers. As American submarines began war patrol operations in December 1941, Japanese naval intelligence officers compiled reports on early American torpedo attacks with barely concealed satisfaction and growing confidence that the submarine threat would prove manageable. Their reports documented failure after spectacular failure, malfunctions so consistent and comprehensive that they suggested fundamental flaws in American torpedo design and American submariner training. On December 14, 1941, just 1 week after Pearl Harbor, the submarine Seawolf under Lieutenant Commander Frederick Warder encountered a Japanese freighter anchored off the southern coast of Mindanao in the Philippines. Warder maneuvered his boat into what seemed like perfect attack position at 3,000 yards range. The target sat stationary and unescorted. He fired 8 Mark 14 torpedoes, the standard weapon of the American submarine force. Each torpedo cost over $10,000 and represented months of production effort at American manufacturing facilities. 7 torpedoes missed entirely, either passing beneath the target or running wild off course. The 8th torpedo struck the freighter squarely amidships. Seawolf's crew heard the dull clang of metal striking metal transmitted through the submarine's hull. No explosion followed. The torpedo, its warhead packed with 643 pounds of Torpex explosive, had hit the target directly and completely failed to detonate. The freighter, its crew now alert to the submarine's presence, got underway and escaped while Seawolf dove deep to avoid the depth charge attack that never materialized because the Japanese vessel carried no anti-submarine weapons aboard. On December 24th, Christmas Eve, the submarine Sargo under Commander Tyrrell Jacobs encountered 4 Japanese cargo ships off the coast of Indochina, steaming in a loose convoy without escort vessels. Jacobs maneuvered his boat into textbook attack positions, firing 3 torpedoes at each of 4 targets for a total of 12 torpedoes from ranges between 1,000 and 2,000 yards. Conditions were perfect for an attack. The sea was calm, visibility excellent, targets maintaining steady courses and speeds. Every single torpedo either missed entirely or malfunctioned. Not a single explosion resulted from 12 carefully aimed shots. Jacobs observed through his periscope as torpedo after torpedo passed beneath targets or struck without exploding or exploded prematurely without causing meaningful damage. He fired his final attack, the last 4 torpedoes in his forward tubes, at a large cargo ship that had actually stopped and was lowering boats to investigate what was happening around them. All 4 torpedoes ran beneath the stationary target without detonating. Sargo returned to Manila Bay on December 30th with her crew completely demoralized, having expended all 24 torpedoes aboard without sinking a single enemy ship. Commander Jacobs filed an extraordinarily critical after-action report stating unequivocally that his torpedoes were running far deeper than their set depths, passing harmlessly beneath targets that should have been hit. The Bureau of Ordnance in Washington, the organization responsible for torpedo development and production, dismissed his complaints with barely concealed contempt. The problem, Bureau officers insisted, lay with submarine commanders who didn't properly understand torpedo maintenance requirements, with crews who weren't performing correct pre-launch procedures, with captains who couldn't execute proper attack approaches. The Bureau's official position held that the Mark 14 represented the most sophisticated, most thoroughly tested weapon in the American arsenal, and that any failures must be due to operator error rather than design flaws. This bureaucratic position would be maintained with extraordinary obstinacy for nearly 2 years, while American submarines fired thousands of defective torpedoes and Japanese merchant ships steamed safely to port, sometimes with American torpedoes lodged unexploded in their hulls. Japanese intelligence officers monitoring American submarine radio traffic, partially decrypting American operational messages through breaks in American codes, and interrogating crews from captured or sunk submarines, compiled detailed reports on American torpedo failures. These reports reached Imperial Naval General Headquarters in Tokyo by early 1942 and were analyzed by intelligence staff officers who drew precisely the wrong conclusions from accurate observations. American torpedoes, they reported confidently, were primitive weapons plagued by fundamental design flaws that reflected inferior engineering. American submariners were poorly trained and lacked the aggressive fighting spirit necessary for effective combat operations. The vaunted American industrial capacity was producing weapons that simply didn't work, ships inferior to Japanese vessels, equipment that broke down under combat stress. This assessment, based on accurate observation of American failures but fundamentally wrong in its interpretation of what those failures meant, would prove to be one of the most catastrophic intelligence judgments in modern warfare history. Throughout 1942, the pattern repeated itself with numbing regularity across the Pacific theater. American submarines stalked targets, maneuvered into attack positions that should have guaranteed kills, fired torpedoes that had every reason to succeed, and achieved nothing. The statistics documented the disaster comprehensively. During 1942, American submarines in the Pacific fired 1,442 torpedoes at Japanese targets. Submarine commanders claimed to have sunk 211 ships, totaling nearly 1.3 million tons of shipping. Post-war analysis of Japanese records conducted by the Joint Army-Navy Assessment Committee revealed the true figures. 109 ships totaling 418,721 tons, barely 30% of what had been claimed. Submarine commanders filed report after furious report documenting torpedoes that ran too deep, that exploded prematurely without causing damage, that struck targets directly and refused to detonate. Japanese merchant captains began reporting American torpedoes lodged unexploded in their hulls as their ships limped safely into port for repairs. Japanese ordnance personnel carefully removed these torpedoes and examined them with professional interest and growing confidence in Japanese technological superiority. These reports reinforced Japanese confidence that the American submarine threat was manageable, that convoy protection resources could be allocated elsewhere, that the merchant fleet could operate with minimal escort and still maintain the logistics pipeline feeding Japan's war economy. This confidence shaped strategic decisions about resource allocation, shipbuilding priorities, and anti-submarine warfare doctrine. Resources that might have been devoted to destroyer escorts, convoy protection systems, and anti-submarine warfare development went instead to battleships and fleet carriers for the decisive surface engagement that Japanese doctrine anticipated. The assumption that American submarines were essentially toothless would persist until late 1943, by which time it would be far too late to implement the convoy protection and anti-submarine measures that might have preserved Japan's merchant marine. The truth was far more complex and ultimately far more ominous for Japan than intelligence assessments suggested. The Mark 14 torpedo, designed during the Great Depression when testing budgets were virtually non-existent, suffered from 3 catastrophic defects that masked each other and made proper diagnosis extraordinarily difficult. Understanding how these defects were finally identified and corrected requires understanding how the torpedo was designed, tested, and deployed under severe budgetary constraints. The Mark 14 torpedo design began in 1931 to replace the Mark 10, a World War I-era weapon equipping older S-class submarines. The Mark 14 was intended for new fleet submarines then under construction, boats like Gato, Wahoo, and Tang that would form the backbone of the American submarine force. Design specifications were ambitious. The torpedo would measure 20 feet 6 inches long, weigh 3,000 pounds, carry a 643-pound Torpex warhead, and achieve a range of 4,500 yards at 46 knots or 9,000 yards at a reduced speed of 31.5 knots. It would be guided by a sophisticated gyroscope system and would run at a set depth controlled by a hydrostatic mechanism. Most ambitiously, it would be equipped with the Mark VI exploder, a magnetic influence device designed to detonate the torpedo beneath the keel of enemy ships, breaking their backs and ensuring kills with a single hit. The Mark VI exploder represented cutting-edge technology for its era. Instead of requiring a direct impact on the target's hull, the Mark VI would detect changes in Earth's magnetic field caused by a ship's steel hull passing overhead. When these magnetic changes reached a predetermined threshold, the exploder would fire, detonating the torpedo beneath the target where the explosion would be most effective against structural integrity. German U-boats had experimented with magnetic exploders during World War I with mixed and inconclusive results. British torpedoes used magnetic exploders with moderate success in certain conditions. The American Mark VI was designed to be more sensitive, more reliable, and more sophisticated than any previous magnetic exploder system. The critical problem was testing, or more accurately, the near-complete absence of proper testing. A Mark XIV torpedo in 1931 cost over $10,000, equivalent to roughly $200,000 in current purchasing power. In the depths of the Great Depression, with naval budgets slashed to the bone and Congress scrutinizing every military expenditure, the Navy proved extraordinarily reluctant to spend money destroying expensive torpedoes in live fire tests against actual targets. Instead, the Mark XIV underwent testing using exercise heads, dummy warheads that could be recovered after test firings and reused indefinitely. These exercise heads were filled with water and compressed air to approximately match the weight distribution of the combat warhead, then fired at targets or through measured ranges to verify depth control and gyroscope function. After firing, torpedoes were recovered, examined for mechanical issues, and reused for subsequent tests. This testing protocol seemed both sensible and economical to Depression-era budget managers. It was also completely inadequate for its intended purpose. The exercise head, while approximating the overall weight of the combat warhead, had a significantly different weight distribution from the actual explosive-filled warhead. The combat warhead contained 643 pounds of high explosive concentrated in the forward section of the torpedo. The exercise head contained water distributed throughout the warhead section with different density and balance characteristics. This difference in weight distribution affected the torpedo's trim and hydrodynamic characteristics in ways that wouldn't become apparent until combat use with actual warheads. Furthermore, no live fire tests were conducted against actual target ships to verify that the exploder would function properly under real combat conditions. The Mark VI magnetic exploder was classified at such high secrecy levels that submarine commanders weren't even allowed to examine it or understand how it functioned. The entire system was accepted for combat deployment based purely on mathematical calculations, laboratory bench tests, and exercise firings that never truly duplicated actual combat conditions. The first defect involved depth control. The torpedo ran 10 to 11 feet deeper than its set depth because the depth control mechanism had never been properly tested with the heavier combat warhead. When engineers increased the warhead weight during final development stages, adding 80 pounds of additional explosive to increase lethality, they failed to recalibrate the hydrostatic depth sensor to account for this change. Additionally, this sensor was poorly positioned on the torpedo's body in a location where water flow created pressure variations that confused the depth control mechanism. As the torpedo accelerated to combat speed, water flowing over the hull created a pressure drop at the sensor location through Bernoulli's principle, the same aerodynamic effect that creates lift on aircraft wings. The depth mechanism, detecting this pressure drop, interpreted it as the torpedo running too shallow and responded by trimming the torpedo to run deeper to reach its set depth. The faster the torpedo travelled, the greater this effect became, creating a systematic depth error that worsened at higher speeds. Every Mark 14 fired in combat during 1941 and 1942 ran far beneath its intended depth. Torpedoes set to run at 10 feet depth, intended to strike a ship at the waterline, actually ran at 20 to 25 feet depth, passing harmlessly beneath targets with keels drawing less than that depth. A simple laboratory test immersing a stationary torpedo in a pool of static water would not reveal this problem because there was no water flow to create the problematic pressure effect. Dynamic tests using exercise heads with depth recorders appeared to show the torpedo running at correct depth, but the depth measuring device in the exercise head suffered from the same sensor placement problem and gave consistently incorrect measurements that matched the incorrect depth control readings. The defect was absolutely real and affected every torpedo fired, but the testing protocol was fundamentally incapable of detecting it. This defect alone would have caused massive operational problems, but its effects were partially masked by the second defect in the magnetic exploder system. The Mark 6 was designed to detonate when it detected the magnetic signature of a ship's steel hull overhead. In theory, this was brilliant engineering. The torpedo would run beneath the target and explode under the keel, where the shockwave and gas bubble would be most effective at breaking the ship's back and causing catastrophic structural failure. In practice, the Mark 6 proved wildly unreliable under actual combat conditions. Earth's magnetic field varies significantly with geographic location, affected by latitude, local geology, and numerous other factors. The Mark 6 had been tested exclusively near the Naval Torpedo Station in Newport, Rhode Island, where magnetic field strength and orientation were suitable for its operation within the parameters engineers had established. In actual combat throughout the Pacific, operating near Java, the Philippines, Guadalcanal, and the Japanese home islands, magnetic field characteristics were entirely different from Newport conditions. The Mark 6, calibrated for Newport's magnetic environment, failed catastrophically in the Pacific combat environment. Some torpedoes exploded prematurely, detonating 50 or 100 yards before reaching their targets when the magnetic trigger detected the target's magnetic signature at excessive range. These premature detonations caused minimal damage while alerting targets that they were under attack and allowing immediate evasive action. Other torpedoes passed directly beneath targets and failed to explode at all because magnetic field changes weren't sufficient to trigger the exploder mechanism in Pacific magnetic conditions. Submarine commanders watching through periscopes as perfect shots resulted in premature detonations or no detonations grew increasingly frustrated with equipment they depended on for mission success and personal survival. They filed detailed after-action reports with specific recommendations that the magnetic feature be disabled entirely in favor of contact detonation only. The Bureau of Ordnance responded bureaucratically by insisting that problems resulted from improper maintenance procedures, incorrect calibration by submarine tenders, or failure to follow proper operating protocols. The Bureau never acknowledged that the weapon itself might be fundamentally flawed for Pacific operations. The deep-running defect and the magnetic exploder defect masked each other in ways that made proper diagnosis extraordinarily difficult, even for experienced submariners. Torpedoes running too deep wouldn't trigger the magnetic exploder because they passed too far beneath the target's magnetic signature to activate the mechanism. Correcting the torpedoes to run at proper depth would presumably fix the exploder problem by bringing weapons within effective magnetic detection range. But when depth was finally corrected in mid-1942 through unauthorized field modifications by submarine commanders, the magnetic exploder continued to malfunction in ways that revealed the third catastrophic defect. The third defect resided in the contact exploder mechanism itself. The Mark 6 incorporated both magnetic and contact firing systems in a single integrated unit. If the magnetic system failed to detonate the torpedo as it passed beneath the target, the contact exploder would theoretically fire when the torpedo physically struck the target's hull. This contact system used a firing pin design that had worked reliably in older torpedoes operating at slower speeds. The Mark 10, which the Mark 14 was designed to replace, achieved a maximum speed of 36 knots. The Mark 6 contact exploder had been designed and tested for that lower speed regime. The Mark 14 ran at 46 knots, 28% faster than the Mark 10, and apparently nobody had properly tested whether the contact exploder would function correctly at the higher impact velocity that this speed produced. When a torpedo traveling at 46 knots strikes a steel hull, the deceleration is nearly instantaneous and extraordinarily violent. The firing pin in the Mark 6 contact exploder was relatively heavy, and it was held in place by a spring that had to be stiff enough to prevent premature firing during normal torpedo handling and launch procedures, but weak enough to allow the pin to move forward and strike the detonator cap when the torpedo hit a target. At the Mark 14's high impact velocity, particularly when the torpedo struck at a 90-degree angle as submarine commanders were specifically trained to achieve for maximum damage, the sudden deceleration caused the firing pin to bind and jam in its housing before it could strike the detonator cap. The friction forces acting on the pin during extreme deceleration exceeded the spring force that was supposed to drive it forward into the detonator. The result was that perfect shots, direct 90-degree angle hits executed exactly as taught in submarine school, were actually the most likely to be duds and fail to explode. Only oblique angle hits, where deceleration was more gradual due to glancing impact geometry, allowed the firing pin to function as intended. This particular defect had actually been discovered and corrected in older torpedo models back in 1922. The solution had been documented. Use a stiffer spring and lighter firing pin components to prevent binding during deceleration. But when the Mark 6 was designed years later, incorporating the revolutionary new magnetic exploder function, this earlier institutional lesson was apparently forgotten or never communicated to the new design team. The contact exploder inherited the old problematic firing pin mechanism without any testing to verify it would work at the Mark 14's substantially higher impact speed. Japanese merchant ships began arriving in ports across the Pacific with American torpedo dents in their hulls, and sometimes with complete unexploded American torpedoes actually lodged in their hull plating. The ultimate humiliation for American submarine crews who had executed tactically perfect attacks while risking their lives in enemy-controlled waters. The cost in American lives and lost strategic opportunities during 1942 and early 1943 was absolutely staggering and directly affected the course of the war. Submarine commanders stalked targets for hours or even days, maneuvering into ideal attack positions at tremendous risk from Japanese anti-submarine forces and air patrols, fired spreads of torpedoes that should have guaranteed kills based on their training and tactical doctrine, and watched in anguish as nothing happened or as premature detonations merely alerted targets without inflicting meaningful damage. The morale impact on submarine crews was severe and cumulative. These were men who had trained for years to become submarine warriors in one of the most demanding specialties in naval service, who took their boats into harm's way despite knowing that submarines suffered the highest casualty rate of any American combat arm, who risked their lives executing perfect attacks against valuable enemy targets, and who saw those attacks fail repeatedly because their primary offensive weapon was fundamentally defective in multiple ways that nobody in authority would acknowledge. Lieutenant Commander Frederick Warder, commanding the submarine Seawolf, encountered an 8,000-ton Japanese transport at anchor in Davao Bay in the Philippines during January 1942. The target sat stationary and unescorted in what represented perfect attack conditions. Warder fired 4 Mark 14 torpedoes from point-blank range with ideal firing solutions. He heard 4 distinct dull clangs as they struck the transport's hull. Not a single torpedo exploded. The transport, suddenly alert to Seawolf's presence, though undamaged, got underway and began zigzagging while radio operators called for air support. Warder reloaded his torpedo tubes with older Mark 10 torpedoes, obsolete World War I-era weapons dating back decades that lacked the Mark 14's sophisticated features, but which actually worked when fired. The first Mark 10 exploded properly against the transport's stern. Warder fired another, which struck amidships and broke the ship's back with satisfying violence. The transport sank rapidly. Warder's after-action report stated with unusual bluntness that the Mark 14 was fundamentally defective and should be withdrawn from service immediately pending complete redesign. The Bureau of Ordnance not only ignored his recommendation entirely, but suggested in its formal response that Commander Warder personally needed additional training in proper torpedo maintenance procedures. Lieutenant Commander Eugene McKinney, commanding the submarine Tambor, fired 8 torpedoes at a Japanese destroyer during April 1942 from a range of only 800 yards. He heard 8 distinct dull metallic clangs as they struck the destroyer's relatively thin hull plating in rapid succession. Not a single torpedo exploded. The destroyer, now fully aware of Tambor's exact position and bearing, immediately counterattacked with depth charges that came close enough to shatter light bulbs throughout the submarine's interior and cause dangerous leaks in multiple hull systems. Tambor barely escaped the counterattack, surfacing after dark in heavy seas to ventilate the boat and assess damage, while crew members worked frantically to repair systems. Japanese intelligence agencies monitoring American submarine radio traffic and analyzing reports from Japanese merchant captains noted that American submarine commanders were explicitly blaming their own weapons for repeated combat failures. This observation was interpreted as clear evidence of American technological inadequacy and poor training standards, rather than as a temporary problem that American engineering capability would eventually solve. Japanese anti-submarine doctrine, which should have been evolving rapidly based on American submarine activity levels, instead remained relatively static because intelligence assessments insisted submarines were not developing into a serious strategic threat to Japanese maritime operations. Japanese anti-submarine resources remained focused primarily on protecting naval task forces rather than merchant convoys carrying the raw materials and supplies that sustained the Japanese war economy. Destroyer escorts and patrol craft, designed primarily for surface combat against enemy warships, generally lacked truly effective sonar systems, adequate depth charge equipment in sufficient quantities, and well-developed tactical doctrine for systematically hunting submarines in open ocean conditions. Japanese naval construction priorities continued focusing on battleships and fleet carriers for the decisive surface engagement that doctrine anticipated, not on unglamorous escort vessels for convoy protection duties. The breaking point for the American torpedo crisis came in 2 separate incidents during June and July 1943, that finally forced even the stubbornly resistant Bureau of Ordnance to acknowledge reality and implement corrections. On June 10, 1943, the submarine trigger under Commander Roy Benson encountered the fleet aircraft carrier Hyo, one of Japan's most valuable capital ships and a critical asset for Japanese naval aviation operations. Benson executed a textbook approach, maneuvering trigger into absolutely perfect attack position at a range of only 1,200 yards, close enough that missing was virtually impossible under any circumstances. He fired 6 torpedoes in a carefully calculated spread pattern designed to ensure multiple hits regardless of any evasive maneuvers the target might attempt. 2 torpedoes missed due to Hyo's emergency turn at maximum speed. 1 exploded prematurely 80 yards short of the target, the underwater detonation clearly visible through trigger's periscope, but causing no damage whatsoever to the carrier. 1 was a complete dud, striking Hyo's hull without detonating despite direct impact. 2 torpedoes hit properly and detonated as designed, causing moderate damage that reduced Hyo's speed and started fires in several compartments. Hyo, protected by destroyer escorts that immediately began systematic depth charge attacks on trigger's probable position, limped away toward repair facilities instead of sinking as she should have with multiple torpedo hits. The carrier underwent emergency repairs at Sasebo Naval Arsenal and returned to active service within 6 weeks. She would survive to participate in the Battle of the Philippine Sea a full year later in June 1944, where her aircraft would attack American carriers and contribute to combat actions that killed American sailors and aviators before she was finally sunk by submarine Archerfish. That single torpedo failure on June 10, 1943, 2 torpedoes out of 6 failing to function as designed, cost the United States the immediate destruction of a fleet carrier, at a time when every carrier on both sides mattered desperately in the balance of naval power across the Pacific. The second incident proved even more definitive in forcing the Bureau to acknowledge reality and implement corrections. On July 24, 1943, Lieutenant Commander Lawrence Daspit, commanding the submarine Tinosa on her second war patrol, spotted the 19,200-ton tanker Tonan Maru No. 3, a massive vessel carrying fuel oil critical to Japanese operations. Daspit maneuvered Tinosa into attack position at 4,000 yards range and fired 4 torpedoes with textbook firing solutions. He observed 2 hits that stopped the massive ship dead in the water. Daspit immediately fired 2 additional torpedoes. Both hit the stopped target. 6 torpedo hits should have been more than sufficient to sink any merchant vessel afloat. Tonan Maru No. 3 remained stubbornly afloat, dead in the water but refusing to sink despite massive damage. With no enemy anti-submarine forces in sight and plenty of time to work, Daspit made a decision that would change American submarine operations. He carefully maneuvered Tinosa into an absolutely perfect position, 875 yards directly abeam of the target, where missing was physically impossible and where every torpedo would strike at the supposedly optimal 90-degree angle that doctrine emphasized. He fired 9 more torpedoes one at a time, observing each one carefully through his periscope despite increasing Japanese machine gun fire from the damaged but still manned target ship. All 9 torpedoes hit the stationary target squarely at the optimal perpendicular angle. Not a single one exploded. Daspit heard the dull thuds of metal-on-metal impact transmitted through Tinosa's hull. Every single torpedo was a complete dud. Daspit, suspecting he might have received a bad production batch from the torpedo manufacturing facility, deliberately kept his last remaining torpedo unfired for detailed analysis by technical experts back at Pearl Harbor. He then cleared the area before Japanese aircraft could arrive from nearby bases. The statistics were damning and irrefutable. He had fired 15 torpedoes at a perfect target under ideal conditions with all the time in the world to aim carefully. 6 had hit without exploding. 9 more had hit without exploding. None had exploded prematurely or run wild. Every single torpedo had functioned perfectly in every respect except for the one absolutely critical function of actually exploding upon impact. Rear Admiral Charles Lockwood, who had assumed command of Submarine Force Pacific Fleet in January 1943, immediately recognized that Daspit's methodical experience represented a controlled scientific experiment conducted under actual combat conditions that proved beyond any doubt that something was fundamentally wrong with the contact exploder mechanism. Lockwood himself was an experienced submariner who had commanded submarines throughout the 1920s and 1930s before advancing to senior administrative positions. He had listened carefully to 2 full years of his submarine commanders reporting similar torpedo failures in patrol reports. He had watched as the Bureau of Ordnance blamed every single failure on operator error, poor maintenance standards, or improper attack procedures by submarine commanders. He had seen the devastating morale impact on submarine crews who were risking their lives executing tactically perfect attacks only to have their weapons fail them at the critical moment. Lockwood ordered immediate comprehensive testing using proper scientific methodology. His staff quickly constructed a testing range where dummy warheads could be dropped from a pier crane onto steel plates positioned at various angles to simulate torpedo impacts at different geometric orientations. The systematic tests rapidly revealed that the firing pin mechanism consistently bound and jammed at high impact velocities, particularly at 90-degree impact angles that generated maximum instantaneous deceleration. The heavier the firing pin and the more sudden the deceleration forces, the more likely the binding became. Direct perpendicular 90-degree hits, the supposedly perfect shots that submarine commanders had been trained since their earliest days to achieve, generated such sudden violent deceleration that the firing pin physically couldn't move fast enough through its housing to strike the detonator cap before binding. The contact exploder was fundamentally defective in its basic mechanical design, and the defect actually became worse with better shooting and more direct hits. The solution came from an unexpected source entirely unrelated to torpedoes. During the Pearl Harbor attack on December 7, 1941, American anti-aircraft gunners had shot down several Japanese aircraft over Oahu. Engineers examining the wreckage at Naval Air Station facilities discovered that Japanese propeller blades were manufactured from lightweight aluminum alloy, rather than the steel used in equivalent American propellers. This material, strong enough for its intended aeronautical purpose, but significantly lighter than steel, suggested a potential solution to the firing pin binding problem. If the firing pin could be manufactured from lightweight aluminum instead of heavy steel, it would have substantially less inertia during the violent deceleration of impact and would be far less likely to bind in its housing before striking the detonator. Testing confirmed the theory worked as predicted. By September 1943, a full 21 months after Pearl Harbor and countless failed attacks, modified torpedoes with aluminum firing pins and other critical design improvements began reaching American submarines at forward bases at Pearl Harbor and Fremantle. The transformation in American submarine effectiveness after September 1943 represented one of the most dramatic capability shifts in the entire history of naval warfare. From December 1941 through August 1943, American submarines had been operating with their primary offensive weapon barely functional under combat conditions. 3 separate catastrophic defects, each one partially masking the effects of the others, had rendered the Mark 14 torpedo unreliable at best and completely useless at worst, depending on circumstances. Submarine commanders had adapted as best they could under impossible conditions, setting torpedoes to run at artificially shallow depths to compensate for depth control problems, even though this risked broaching and revealing their positions, deactivating magnetic exploders against direct orders to prevent premature detonations, attempting oblique glancing angle shots instead of the perfect perpendicular 90-degree angles they had been taught throughout their training. But these were merely workarounds and temporary measures that addressed symptoms without curing the underlying disease affecting the weapon. After September 1943, with all 3 fundamental defects systematically corrected through proper engineering, the Mark 14 finally became the devastating weapon it had originally been designed to be. Depth control now functioned properly and reliably. The magnetic exploder had been permanently deactivated in favor of contact detonation only, eliminating the most unpredictable variable. The contact exploder now functioned reliably at all impact angles and velocities. Submarine commanders who had learned their deadly trade in the brutal school of hard combat experience, who had survived 2 full years of operations despite fundamentally defective weapons, now suddenly possessed torpedoes that actually worked consistently. The effect on Japanese shipping was immediate and utterly catastrophic. Japanese naval planners, observing early American submarine operations throughout 1942 and early 1943, had concluded with bureaucratic confidence that the submarine threat was strategically manageable and didn't require drastic resource reallocation. Convoy protection resources continued being allocated primarily to protect major naval task forces and critical troop convoys rather than routine merchant shipping. Destroyer escorts and patrol craft remained focused on protecting battleships and carriers for the decisive fleet engagement. Anti-submarine warfare doctrine continued emphasizing protection of high-value military targets rather than systematic convoy escort. The vast merchant fleet carrying raw materials from conquered territories throughout Southeast Asia back to Japan, and carrying finished military goods and equipment from Japanese factories to forward bases and combat zones, continued operating with minimal escort protection under the comfortable assumption that American submarines simply weren't effective enough to pose an existential threat to Japanese maritime logistics. This fundamental assessment would prove catastrophically wrong once American torpedoes began working reliably, and American submarine commanders could finally prosecute attacks with weapons they could trust. The submarine flasher, commanded by Commander Reuben Whittaker, intercepted a convoy off Indochina on December 22, 1944. Whittaker maneuvered his boat into ideal attack position and fired 6 torpedoes at 3 tankers sailing in close formation. All 6 torpedoes functioned perfectly as designed. 3 tankers, the 10,000-ton Omarosan Maru, the 9,200-ton Arita Maru, and the 9,200-ton Ottawasan Maru, all carrying absolutely critical fuel oil from the Dutch East Indies refineries to fuel-starved Japan, went to the bottom in less than 20 minutes. In a single perfectly executed attack, Whittaker had sunk over 28,000 tons of shipping and sent hundreds of thousands of gallons of irreplaceable fuel oil to the ocean floor, where it did Japan's war effort no good whatsoever. The submarine Barb, commanded by the aggressive Commander Eugene Fluckey, achieved even more spectacular results that would make him legendary among submarine commanders. On her 11th war patrol in 1945, Barb sank 17 ships totaling over 96,000 tons, setting an all-time record for tonnage sunk on a single patrol that would never be exceeded by any submarine. On June 23, 1945, operating off the China coast in dangerous shallow waters, Fluckey executed a devastating attack on a convoy anchored in Namquan Harbor. In just 54 minutes of furious action with perfect torpedo performance, Barb sank 4 ships totaling over 15,000 tons in a single sustained attack. These were not lucky hits or random successes resulting from favorable circumstances. These were precisely executed attacks using weapons that now functioned exactly as originally designed, delivered by highly experienced submarine commanders who had learned through years of bitter combat experience exactly how to employ their boats and weapons to absolutely maximum tactical effect against Japanese shipping. The statistics comprehensively documented the dramatic transformation in American submarine effectiveness once weapons were fixed. During 1942, with defective torpedoes, American submarines fired 1,442 torpedoes and claimed 211 ships for 1.3 million tons sunk. But actual confirmed results were only 109 ships for 418,721 tons. During 1943, as torpedo problems were gradually identified and corrected, submarines fired 3,937 torpedoes and sank 284 ships for 1,349,473 tons. During 1944, with fully functional torpedoes throughout the force, submarines fired 6,902 torpedoes and sank 192 ships for 2,388,000 tons. The effectiveness improvement was approximately tenfold once torpedoes began functioning consistently as designed. By the end of the Pacific War, American submarines had sunk 1,178 Japanese merchant vessels totaling 5,053,491 tons, representing an overwhelming 54.6% of all Japanese shipping losses from all causes combined. More critically, from a strategic perspective, American submarines had also sunk 201 Japanese naval vessels, including the massive aircraft carrier Shinano at 72,000 tons, the largest aircraft carrier ever constructed and the largest warship ever sunk by a submarine in the history of naval warfare. The cumulative toll on Japan's war economy was utterly catastrophic and fundamentally altered the entire strategic balance across the Pacific theater. Japan was an island nation absolutely and completely dependent on seaborne logistics for economic survival. Raw materials, including iron ore, bauxite, rubber, and countless other critical resources from conquered territories throughout Southeast Asia, China, and the Dutch East Indies, had to be shipped by sea to Japan for industrial processing. Finished military equipment, including aircraft, weapons, ammunition, and vehicles, had to be shipped from Japanese factories back to forward bases and active combat zones. Food imports were absolutely essential to feed the civilian population since Japan had never been agriculturally self-sufficient. Most critically, oil from refineries in the Dutch East Indies and Borneo was essential to literally every aspect of the war economy and all military operations. By January 1945, the Japanese merchant fleet had been systematically reduced to barely 1/4 of its December 1941 strength through relentless submarine attacks. Tankers carrying desperately needed oil from the East Indies were being sunk faster than they could complete round trips to Japan. Cargo ships bringing raw materials to Japanese factories were going to the bottom with their holds still full of critical resources. Food imports had declined to crisis levels where rationing throughout Japan was approaching actual starvation conditions in some areas. The industrial consequences rippled through every single aspect of Japan's entire war effort with devastating cumulative effects. Oil refineries on the Japanese home islands were forced to shut down completely for lack of crude oil from the East Indies. Japan's domestic petroleum production capacity, which had never been remotely sufficient for military needs, even with substantial imports from captured territories, simply stopped functioning. Aircraft factories ceased production for lack of aluminum and other critical materials. Ammunition plants closed for lack of explosives and brass. Shipyards ran out of steel plate. The Imperial Japanese Navy, once the third most powerful navy in the world, and a force that had decisively defeated the Russian Navy at Tsushima and completely dominated the Western Pacific in early 1942, was reduced to near-total immobility by lack of fuel oil for its capital ships. Army divisions scattered across China, Southeast Asia, and isolated Pacific islands steadily withered from lack of supplies and reinforcements that simply never arrived. Ammunition stocks, replacement weapons, medical supplies, food rations, all had to be shipped from Japan by sea, and increasingly those ships were torpedoed and sunk before reaching their destinations. Troops on isolated island garrisons went months without any resupply whatsoever as submarines systematically sank the cargo ships that represented their only lifeline to Japan. Battle casualties couldn't be replaced with fresh troops as transport ships carrying reinforcements were intercepted and torpedoed. The Japanese army, which had conquered vast territories and decisively defeated Chinese, British, Dutch, and American forces during the opening months of the war, found itself slowly starving in fortified positions because the maritime logistics system that sustained operations across the Pacific was being systematically destroyed by American submarines. The Japanese home islands themselves faced potential mass starvation as food imports effectively ceased. Japan had never been remotely self-sufficient in food production, instead relying heavily on imports from Korea, Formosa, and throughout Southeast Asia to adequately feed its growing urban population. By 1945, those critical food imports had been reduced to an unsustainable trickle by submarine attacks on cargo vessels. Urban populations in Tokyo, Osaka, Nagoya, and other major cities faced increasing severe hunger as rice rations were cut repeatedly. Black markets flourished as desperate civilians paid absolutely exorbitant prices for basic food. The government implemented increasingly draconian measures attempting to maintain social control, but the simple brutal reality was that Japan physically couldn't feed its population without substantial imports, and American submarines had systematically cut those imports to completely unsustainable levels. American strategic bombing by B-29s, which received enormous attention in popular accounts and dominated post-war assessments for decades, was actually secondary to the submarine blockade in terms of destroying Japan's fundamental ability to continue waging war. The Army Air Force's massive firebombing campaign against Japanese cities, while absolutely devastating to civilian populations and psychologically traumatic on an enormous scale, actually had relatively limited immediate impact on Japan's war economy, for the simple reason that the economy had already been fundamentally crippled by lack of raw materials. Factories physically couldn't operate without steel, aluminum, coal, and oil, regardless of whether American bombers were actively destroying them. The atomic bombs dropped on Hiroshima and Nagasaki on August 6 and 9, 1945, provided the Japanese government with a face-saving pretext to surrender without admitting conventional military defeat. But Japan was already comprehensively defeated, both economically and militarily, by that point. The nation simply couldn't continue fighting, regardless of tactical battlefield outcomes, because the entire economic foundation of its war effort had been systematically destroyed by submarine operations. The final irony involves the Type 93 Long-Lance torpedo, the devastating weapon that had terrified Allied navies throughout 1942 and 1943, and that Japanese intelligence had repeatedly cited as definitive evidence of Japanese technological superiority over American weapons. By 1944, as American forces systematically developed effective countermeasures and improved tactical doctrine to defeat it, the Long-Lance became increasingly irrelevant to the war's ultimate outcome. Radar warning systems gave American ships critical advance notice of approaching Japanese surface forces, allowing evasive maneuvers and tactical positioning before torpedoes could ever be launched. Substantially better damage control techniques and training helped American ships survive torpedo hits that would have certainly sunk them earlier in the war. Improved tactical formations specifically designed to minimize exposure to torpedo attacks significantly reduced the effectiveness of long-range torpedo salvos. Most importantly, increasingly aggressive American surface forces, supported by absolutely overwhelming air power, were sinking Japanese torpedo launching platforms faster than Japan could possibly replace them from dwindling industrial capacity. By mid-1944, American cruisers and destroyers engaged Japanese surface forces with tactical confidence born of multiple technological advantages that outweighed Japanese torpedo range superiority. American warships possessed radar fire control systems, enabling accurate gunnery at night and in poor visibility conditions. They had completely reliable radio communications, enabling sophisticated coordinated fleet actions. They enjoyed decisive numerical superiority in virtually every engagement. The weapon that should have been Japan's decisive advantage in surface combat had become essentially a strategic sideshow as American submarines systematically destroyed the merchant fleet that kept the entire Japanese war machine minimally operational. Japanese destroyers and cruisers, originally designed and built specifically to deliver devastating torpedo attacks in aggressive night surface actions, found themselves increasingly relegated to desperate escort duty, attempting to protect what little remained of the merchant fleet, a defensive role for which they were poorly suited and inadequately equipped, and which they performed quite inadequately. The Battle of the Philippine Sea in June 1944 perfectly illustrated how completely the balance of naval power had shifted in American favor. On June 19, 1944, the submarine Kavala, commanded by Commander Herman Kossler, intercepted the Japanese fleet carrier Shokaku as the carrier was recovering aircraft after launching strikes against American invasion forces. Kossler fired 6 torpedoes at a range of 1,200 yards. 4 struck home with devastating effect, the massive explosions detonating aviation gasoline storage areas and triggering catastrophic secondary explosions throughout the ship. Shokaku, veteran of Pearl Harbor, Coral Sea and Santa Cruz, flagship of Japanese carrier operations in early 1942, sank in minutes, taking 1,263 crew members down with her. Hours later that same day, the submarine Albacore, commanded by Commander James Blanchard, fired a single torpedo at the brand-new armoured carrier Taiho, Japan's most technologically advanced carrier and current flagship of the mobile fleet. The torpedo struck forward, causing what initially appeared to be relatively minor damage that wouldn't prevent flight operations. Japanese damage control officers, confident that the heavily armoured carrier could easily handle a single torpedo hit, made a catastrophic error. They attempted to ventilate accumulating gasoline fumes by running the ship's entire ventilation system at maximum capacity, inadvertently spreading explosive vapours systematically throughout the vessel. 7 hours after the initial torpedo hit at 15:32, Taiho exploded in one massive detonation that blew out her sides and broke her back. She sank rapidly, taking 1,650 sailors with her, including Vice Admiral Jisaburo Ozawa's entire operational staff. These were absolutely not lucky shots or fortunate accidents resulting from favorable circumstances. These were precisely executed attacks using weapons that now functioned exactly as designed against critically valuable targets whose loss Japan could not remotely afford at this stage of the war. Shokaku and Taiho together represented 40% of Japan's remaining large carrier force. Their loss in a single day, both to American submarines using reliable torpedoes, permanently crippled Japanese naval aviation at precisely the critical moment when it desperately needed to face the American fast carrier task force in the Philippine Sea. The subsequent Battle of the Philippine Sea, known to American pilots with dark humor as the Great Marianas Turkey Shoot, destroyed Japanese carrier air groups so thoroughly that Japanese carriers would never again pose any serious threat whatsoever to American naval forces. American carrier aircraft shot down over 600 Japanese aircraft in essentially a single day of sustained combat, while losing only 29 of their own planes. The submarines had struck first and most decisively, eliminating two absolutely irreplaceable fleet carriers before American carrier aircraft even engaged. Japanese naval planners, still operating under intelligence assessments from early in the war that had consistently rated American submarines as merely a secondary threat, had positioned their most valuable carriers in waters routinely patrolled by American submarines without anything approaching adequate anti-submarine screening. The result was utterly catastrophic for Japanese naval aviation. The loss of these carriers meant that even if Japanese naval aviation could somehow train adequate replacement pilots and rebuild depleted air groups, there simply weren't sufficient carriers remaining to embark them for operations. Japanese naval aviation, which had so completely dominated Pacific skies throughout 1942, was effectively finished as an operationally effective fighting force by mid-1944, and American submarines had delivered the absolutely critical blows that made that defeat mathematically inevitable. The Battle of Leyte Gulf in October 1944 comprehensively demonstrated the cumulative strategic effect of the entire submarine campaign and the complete reversal of the technological balance between American and Japanese forces. On October 23, 1944, as Admiral Takeo Kurita's powerful center force approached the Philippines through the narrow Palawan Passage threading through restricted waters on the approach to Leyte Gulf, the submarines Data and Dace intercepted the Japanese column. The submarines had been positioned along the expected transit route based on excellent intelligence from sophisticated code-breaking operations, demonstrating the complete integration of communications intelligence with tactical submarine operations that characterized American submarine warfare by late 1944. At 5:32 in the morning, Data, commanded by Commander David McClintock, detected the Japanese column on radar at 30,000 yards range. He skillfully maneuvered his boat into ideal attack position, methodically tracking the force for 4 full hours, while simultaneously radioing detailed contact reports that allowed Dace under Commander Bladen Claggett to position herself for a coordinated attack from the opposite side. At 9:27, Data fired 6 torpedoes at the heavy cruiser Otago, which happened to be Admiral Kurita's flagship. 4 torpedoes struck home, the violent explosions tearing enormous holes in Otago's hull, plating well below the waterline. Otago lost all electrical power immediately, her engineering spaces flooded catastrophically, and she began sinking rapidly by the bow. Admiral Kurita and his operational staff hastily abandoned ship, swimming desperately in oil-covered water as destroyers maneuvered frantically to rescue them from the sea. Otago sank at 9:55, just 28 minutes after the torpedo hits, taking 360 of her crew of 800 down with her. Data immediately shifted targets without hesitation, firing 4 torpedoes at the heavy cruiser Takao. All 4 torpedoes hit with devastating effect, the explosions literally breaking Takao's back and flooding multiple major compartments. Takao didn't sink immediately, as her damage control crews managed to isolate flooded sections and barely keep her afloat. But she was crippled so severely that she had to withdraw completely from the battle, escorted by 2 desperately needed destroyers. She would spend the entire remainder of the war under continuous repair at Singapore, never returning to operational service. Dace, firing from the opposite side of the Japanese column in perfect coordination, targeted the heavy cruiser Maya, launching 4 torpedoes at 9:56. Multiple torpedoes struck home, the explosions breaking Maya's keel and detonating her magazines in catastrophic secondary explosions. Maya broke completely in half and sank in only 8 minutes, taking 769 of her crew of 1,000 sailors down with her in the rapid sinking. In a single brilliantly coordinated attack lasting less than 30 minutes, 2 American submarines had sunk 2 modern fleet cruisers, crippled a third so badly she was out of the war, and left the commander of the center force without his flagship, without his staff, without his command center, and without effective operational communications at the absolute opening of the largest naval battle in human history. Admiral Kurita eventually transferred his flag to the battleship Yamato, but he had permanently lost his communications equipment, his operational charts, his experienced staff officers, and many hours of absolutely critical time during this chaotic transfer. His subsequent controversial performance at Leyte Gulf, characterized by apparent hesitation, confusion, and ultimately his inexplicable withdrawal despite having American landing forces at his mercy, may have been at least partially attributable to the submarine attack that completely disrupted his command structure at the most critical possible moment. The broader strategic impact of Leyte Gulf was that the Imperial Japanese Navy effectively ceased to exist as any kind of meaningful fighting force. Japan lost 1 fleet carrier, 3 light carriers, 3 battleships, 6 heavy cruisers, 4 light cruisers, and 11 destroyers in the sprawling multi-day engagement. The ships that somehow escaped destruction, including the legendary super battleship Yamato, were effectively trapped in home waters by acute fuel shortages caused directly by submarines sinking tankers substantially faster than Japan could possibly replace them with remaining shipbuilding capacity. When Yamato sortied in April 1945 for a desperate suicide attack on American forces at Okinawa, she carried fuel for only a one-way voyage because that was literally all Japan could provide. She was sunk by overwhelming carrier aircraft attack without ever reaching her target, going down with 2,498 of her crew of 33,032. The remaining Japanese carriers, without fuel to train, desperately needed replacement pilots or to conduct any meaningful combat operations, sat idle at anchor while their precious aircraft were systematically expended in kamikaze suicide attacks. The decisive fleet battle for which Japanese naval doctrine had meticulously prepared for 40 years had been fought and comprehensively lost, not through inferior tactics or insufficient courage from Japanese personnel, but because the complex logistics system that kept the entire fleet operationally functional had been systematically destroyed by American submarines that Japanese intelligence had catastrophically underestimated. By early 1945, Japanese shipping losses had reached absolutely apocalyptic levels that made any continuation of the war economically impossible, regardless of military willpower. American submarines operating with completely reliable torpedoes, sophisticated intelligence about convoy routes from highly effective code-breaking operations, and aggressive experienced commanders who had learned their deadly craft in years of brutal combat, intercepted and destroyed Japanese shipping at rates Japan absolutely could not sustain. In January 1945, American submarines sank 252,000 tons of Japanese merchant shipping. In February, 182,000 tons. In March, 269,000 tons. In April, 186,000 tons. Each month, submarines were sinking the equivalent of Japan's entire monthly shipbuilding capacity several times over. Each individual sinking represented not just lost cargo, but lost experienced crews, lost irreplaceable shipbuilding capacity, lost strategic mobility, and another inexorable step toward complete economic collapse. Japanese shipyards, working frantically to replace mounting losses, could build approximately 300,000 tons of merchant shipping per year at absolute maximum theoretical capacity, assuming they somehow had sufficient steel, adequate workers, and reliable electrical power, all of which were increasingly scarce throughout 1945. American submarines were systematically sinking more than 3 times that tonnage every single month. The mathematics were brutally simple and absolutely inexorable. Japanese merchant shipping capacity was declining inevitably towards zero, regardless of anything Japan's navy or army could possibly accomplish on any battlefield anywhere. By August 1945, when the war finally ended, Japan had virtually no merchant marine remaining whatsoever. The handful of ships that had somehow survived did so primarily by hiding in heavily defended ports, not daring to venture into open waters patrolled by American submarines that controlled the seas as completely as any naval force in recorded history. The human cost of the submarine campaign for Japanese merchant sailors remains extraordinarily difficult to quantify precisely, but was certainly devastating on a massive scale. These men, mostly civilians serving aboard merchant vessels, died by the thousands as submarines torpedoed their ships, trapped below decks as torpedoes blasted holes through hulls, drowning in oil-filled waters, burned alive when tankers exploded, dying slowly of exposure in lifeboats that drifted for weeks without any rescue. The Imperial Japanese Navy maintained no effective rescue service whatsoever for merchant sailors, viewing them as essentially expendable civilian personnel rather than critical national resources whose survival should be actively prioritized. Many American submarine commanders, operating under unrestricted submarine warfare orders but retaining fundamental human compassion, routinely surfaced after attacks to offer survivors water, food, and directions to the nearest land. Japanese military personnel, thoroughly indoctrinated to view Americans as barbaric racists, frequently refused this assistance, swimming away from potential rescue or refusing help rather than accepting aid from enemies they had been systematically taught were less than human. The story of Japanese intelligence dismissal of American torpedo improvements stands as a profound case study in how intelligence failures compound systematically into strategic catastrophes. Japanese naval intelligence officers, confronted with absolutely accurate evidence of spectacular American torpedo failures throughout 1942, drew the superficially logical conclusion that American weapons were fundamentally flawed and would remain so indefinitely. This flawed assessment shaped critical resource allocation decisions that prioritized decisive battle doctrine over convoy protection and anti-submarine warfare capabilities. When American engineers systematically identified and methodically fixed every single torpedo defect through proper scientific engineering, Japanese intelligence agencies proved remarkably slow to recognize the dramatic transformation and even slower to convince operational commanders to adjust strategy and tactics accordingly. By the time Japanese naval planners finally understood the true magnitude of the submarine threat they faced, it was already far too late to matter. The ships had already been sunk. The merchant marine had been systematically destroyed. The economy had been strangled beyond any possibility of recovery. Victory in the Pacific War was ultimately determined not by the spectacular carrier battles at Midway and the Philippine Sea that captured public imaginations and dominated newspaper headlines, but by the grinding, relentless attrition of submarine warfare that systematically destroyed Japan's fundamental ability to sustain combat operations anywhere. The weapon that Japanese intelligence had openly mocked as clear evidence of American technological incompetence became the primary instrument